paper on the discrete choice experiments related to climate change on the rice varieties. So what was the willingness to pay for the farmer? So this is the paper again related to the transportation sector. But in this paper, we'll be covering the willingness to pay for the labeled cars. So this study was being done in 2017. So it was prior to the COVID period. And this paper has been recently accepted in the Transportation Journal. And the paper is already uploaded on the Google Drive for you all to read. So this is the title of the paper, The Preferences for the Energy Efficient Cars in Delhi, using a discrete choice experiment, and where we are exploring the regulatory and the non-regulatory interventions. This is a joint work being done by me, Aden and Sangeeta ma'am. So all three of us had done this paper and it will be coming in Transportation Journal. So before going into the dynamics of the discrete choice experiment, first I would like to motivate like why did we did this study, what are the implications, and then we'll formally talk about how did we design our choice experiment. So we all know air pollution is affecting your human health, climate change. So its implications, and these implications is a major issue in mega cities, especially Delhi. I think from last few months, starting from October itself, the AQI is above 300, comes sometimes above 400. Every alternate day, GRAP 3 measures are being introduced in Delhi, then removed. You all know it is affecting the health, even the students' classes turn online. So that is what we are trying to capture in this paper. How can we reduce air pollution? So in India, the transportation sector is accounting for 72% of the emissions are coming from the transportation sector. So smog in Delhi is coming from the crop burning, from industrial pollution, vehicle emissions. So this paper is trying to target how can we reduce the vehicle emissions which are coming from the transportation sector. So a popular strategy to reduce the vehicle emissions could be that we say follow fuel efficiency standards, or we could follow fuel efficiency labels. So we have these kind of the standards and labels for appliances. So in India, we have Bureau of Energy Efficiency, which is looking about for these energy efficiency labels. So like say you have air conditioner. You all would have seen a star labeled on an air conditioner, ranking from 1 star to 5 star. On refrigerators, even on laptops, which you would be using today, you all have a star label on these. So then why not have these labels on the cars also, to indicate that this car is more fuel efficient as compared to the others. So we have these standards for appliances, fuel efficiency standards for cars. So we are proposing that government should consider having fuel efficiency labels. So in the Global Fuel Economy Initiative, the government has proposed these labels, but they are yet to be implemented formally, have these labels. These labels are already there in the developed countries, but not much adopted in developing countries, especially for cars. So in New Delhi, my focus area is within India. We are focusing on Delhi because in Delhi the emissions are very high. We had the emissions of 255.8 million tons of CO2 in 2021. Total number of registered vehicles in Delhi were 11.4 million. These number of registered vehicles are much higher than the number of vehicles we have in Chennai and Mumbai combined. So combining the two states, the number of vehicles in Delhi are much higher than that. The PM 2.5 level in Delhi is 30 times more than the level what WHO considers safe. So in the paper by Sangeeta ma'am had actually estimated if the PM 2.5 level, it reaches to what WHO considers safe, my life expectancy is expected to reduce by 10.3 years. So that is the impact which you can have if you are improving your PM 2.5. So if you are reducing the CO2 emissions. So taking this into account, so this is an example you can see for a fuel efficiency label. So it is ranking from 1 star to 5 star, where 5 star indicates that it's the most fuel efficient car. Then you have least fuel efficient car will be your 1 star labeled car. So this is an example where it is giving the information related to fuel economy, with a petrol variant, how many kilometers per liter, mileage information. So that kind of providing the information. That is the idea of these labels. So to consider these labels, what is the willingness to pay for the consumers for these fuel efficient labels? In my study, we use a methodology of discrete choice experiment. So as ma'am highlighted in the rice paper also, the data was not available. So similar issue we were facing in this, that there is a lack of the data. So we tried to design a discrete choice experiment. The objective was to analyze the consumer's willingness for the fuel efficiency labels in New Delhi. So while designing this discrete choice experiment, in this paper, we added two novelties to this paper. First was, we wanted to see the impact of some regulation which is being imposed. So like what policy implications you can design from that. So Edan had already covered about this in his lecture, but I'll explain it in more detail. So what regulation we have? So we gave them a regulation like an incentive. So how with that incentive your willingness to pay will increase for the efficient cars for the labels. And the second novelty which we introduced was, we wanted to explore the impact of behavioral motives. So how your motives, is it your internal urge to contribute towards the environment? Are you really concerned about the environment? Is that making you buy a more efficient car? Or say, is this the impact of your friends, your peer group, your colleagues, neighbors? So is their impact making you buy a more fuel efficient car? So we introduced two novelties in this paper. One was where we covered the impact of regulatory incentive, and second was behavioral motives. So I'll go into the detail of both the novelties and show how we had modeled these novelties. So first one was the regulatory incentive. So in Delhi, you all are aware of the odd even scheme which was being there in Delhi. So in 2015-16, this odd even scheme had been introduced, though it's not introduced in the recent times, but this study was done in 2017. So during that time, odd even scheme was more popular. Now also it keeps on coming that they might impose this odd even scheme. So what we have in this odd even scheme? So your odd numbered registered plates cars would be allowed to be driven on odd dates. Even numbered registered plates cars will be allowed to be driven on even dates. But we added a twist to this regulation. So what we did was, if you buy a more fuel efficient car, then you are exempted from this odd even regulation. So like if you buy a high star, say a 5-star labeled car, you can drive it on all days, irrespective of your whether it's your odd numbered plate car or a even numbered plate car. So to employ this strategy, we followed a split sample approach, which Iran had already highlighted a split sample approach. So what we did in this split sample approach is, we informed half of the respondents about this regulatory incentive. So we informed half of the respondents that if you buy a high star labeled car, you can drive it on all days. There will be no regulation which will be there for you. But for the other half of the sample, there was no incentive being given to them. So we divided our samples into two halves. For half sample, there was an incentive scheme that we call it as an informed sample. They are informed about driving restrictions, and the other half there was no incentive. So this is similar to a scheme which we have it in Mexico, like Mexico Ho No circular scheme, where you are not allowed to drive the cars on all days. There is a kind of a restriction, driving restriction, which is being imposed. So that was the first novelty of this paper. And New Delhi residents were already familiar with this odd even regulation. And second was the behavioral motivation. So if we compare our studies with the previous literature, the previous literatures in developed countries, they have talked about how the labels, what is the willingness to pay for the labels, for the fuel efficiency labels, as well as for the energy labels for the appliances. But such studies are not there for India and especially for Delhi. Plus, in addition, the second is, none of the previous studies, even in the developed countries, they have tried to combine labels with the incentives. So that's the one of the novelty, that we combine labels with incentives. And in addition to that, we also see the impact of the behavioral motivations. So this is just a newspaper article on the odd even rule on day 1. It's a 2016 article when the odd even rule was introduced. So I have explained how we incorporate the the regulatory incentive. The second part which we are incorporating is the behavioral motivations. So how your friends and peers impact your choices. So to incorporate the behavioral motivations, we asked the respondents with the Likert scale questions. So it's like a Likert scale ranging from 1 to 5, where 1 indicates strongly disagree, 2 will be disagree, 3 is like undecided, 4 agree, and 5 would be strongly agree. So ranging from strongly disagree to strongly agree, we ask the respondents to rate on a Likert scale. So regarding the behavioral motivations, I grouped those behavioral motivations into 4 categories. One was your intrinsic motivation. So it's like your warm glow effect. Give something out of the act of selflessness. What is your internal urge to contribute towards the environment? So that was the first behavioral motivation which we covered, was intrinsic motivation. So we asked 3 questions for intrinsic motivation. So a couple of questions were asked on each of them. So in intrinsic motivation, we asked the respondents, I feel personally obliged to save energy. So rank them on a scale of 1 to 5. While purchasing household items like air conditioner, do I take into account how my use will affect the environment? We introduced it for appliances because these labels are already there for appliances. I am willing to purchase energy efficient star labeled electrical appliances even if they are more expensive. So you all know, like if you buy a labeled alternative, a 5-star labeled car or a 5-star labeled appliances, they will definitely cost you more. But at the same time, you will have some private benefits in the form of energy savings, fuel cost savings which you can derive. Plus, you will be deriving some public benefits in the form of reduced CO2 emissions. But then to buy a energy efficient appliances, you will have to pay more. So, are you willing to purchase energy efficient appliances even if they are more expensive? So, these were the 3 questions which we covered on intrinsic motivation. Second behavioral attribute which we wanted to include was extrinsic motivation, which we call it as networks. So another novelty of this paper is to see the impact of social network, green networks. So we incorporated green networks in the form, like say if the other consumers are buying that product, will it increase your willingness to pay? How your choices are being influenced by your peers, by your neighbors, colleagues. What happens, like if most of your friends are buying an electric vehicle, buying an energy efficient car, will you buy it? So to incorporate this, we incorporated the network effects in 2 forms. One, we incorporated it in the choice experiment itself, and second, we incorporated it in the form of the Likert scale questions for the behavioral motivations. So these were the 2 things on the basis of which we incorporated the extrinsic motivation. So questions were, these were 2 separate questions. I consider recommendations from family, friends, neighbors while making choices to buy cars, household appliances, and a separate question on colleagues, because sometimes the influence of your colleagues is different from your friends, neighbors. So these were the 2 questions which are included on the extrinsic motivation, your network effect. Second way network was discussed as an attribute. We'll talk about choice experiment. So there I'll talk more about the networks. Third behavioral motivation which we introduced in our study was social interaction. So how well we wanted to document how well you are interacting. So we documented in the form of, say, how many times do you meet your friends and relatives. So for colleagues, obviously you will be meeting at workplace. So we tried to change and incorporated it in the form like how many times you are meeting outside during a month. Then you can say if you are inviting your friends, relatives, colleagues to your home. So that would be like another more level of social interactions if you are regularly inviting them for dinner, lunch. So we incorporated a separate question on that. So say how often do you invite your relatives, friends, colleagues to your home? So this was the another question which we introduced. So it's like, do you invite them, say, less than 2 times in a month, 2 to 6 times in a month, or more than 6 times in a month? So based on that you can rank how many times you are meeting it. So this was the another novelty of this paper, to incorporate social interactions. Then within social interactions, we incorporated one additional parameter which is the trust factor. So it's like if you trust more, that means you will be following their decisions. If you trust that, okay, my friend is he has made a good choice, he's buying a good car, I should follow it. So these trust factors I incorporated by these questions like, are you willing to lend your household items to the neighbor? So if you trust, only then you will be lending. Do you keep your house or car keys with your neighbor? If you are leaving home for some work, you might want to keep their car keys. Or say, sending your children to the neighbor's home. That is also a trust which you have. So we incorporated questions like how often do you leave house, car keys or your children to your friends, to your neighbors. So that was the another question where we incorporated social interaction. So that was the third attribute: intrinsic motivation, extrinsic motivation, social interaction. Then to capture behavioral motives, we included another question of your environmental knowledge. So how aware are you about the environment? So we had shown them this energy efficient label for the appliances. So we asked them, do you recognize this label? Which agency is giving this label? So it's like Bureau of Energy Efficiency is giving this label. Some basic questions like how is soil erosion can be prevented? When is the World Environment Day celebrated? So greenhouse gas emissions is caused by what factors? So a multiple choice questions, and we asked them to give the answers to that. So with this we could actually judge how well they know how well are they aware about the environment. Do they have a good environmental knowledge or not? So these were the novelties. One was your regulatory incentive. Second was the behavioral motivations. So for these novelties, we estimated consumers' willingness to pay for the energy efficient appliances. So before I go to choice sets, any questions if you have? Then I'll go further. Yes.
You mentioned that you had taken a separate effect for your friends and for your colleagues. So how was that? What was the
I have in my results I've documented it combined, but initially we thought we can actually at least take a separate effect. So there were just two separate questions. So one question was, do I consider recommendations from family, friends, neighbors while making decisions to buy your household appliances? Second, same question, just instead of friends, family, neighbors, I asked colleagues.
But what was the motivation of segregating the two in terms of social interaction?
So sometimes I wanted to see how well are you influenced by your friends, neighbors, colleagues, and especially for social interactions when you are inviting them to the home. So with colleagues you are meeting them daily already. So inviting to home is not much common, which is more to your friends and relatives.
So did you find that colleagues had more effect on
I didn't specifically go for incorporating separate impact. I just considered them as together. Any other questions you have? Yes.
About the sample, I just wanted to ask how. About the sample, that's a question I always have with studies like this. That is, how do you adjust for, say for example, if you're finding people in your circles or whatever it might be, how do you adjust for the socio-economic status of the people? Because these behaviors will really differ.
I'll be talking about the sample in detail, but basically since this is for car owners, so we tried to capture those who are higher and the upper middle class people. So we specifically targeted that sample. But I'll be talking about the sampling in a while. Any other question? Yes.
These are the questions that are used as additional controls apart from the choice set which will be
Yes,
present.
these are used as an additional.
Okay, so all these will be categorized into different.
Yes, I'll be coming to that, how we use
Okay.
these variables.
Okay, thank you.
Any other question? Okay, we can continue, and then if you have more questions, we can take it later on after the choice set. So these were the few studies in the literature which had talked about the efficiency labels, how much you are willing to pay for these labels, but none of these studies had combined fuel efficiency label with the regulatory incentive, especially in this form of an odd even rule. So this is what is the choice set. So we all know a discrete choice experiment, it's already talked about, is a hypothetical scenario. So before deciding these choice sets, we also did a focus group studies. And after even documenting this choice set, we did a pilot study to see that whether we want to change any of our attributes, how are these attributes impacting. So we did a pilot study as well as the focus group discussions to decide on the various attributes and its levels. So based on that, in our study, we decided to follow 3 alternatives. So in discrete choice experiment, we give the respondents different alternatives. Each alternative is characterized by a different set of the attributes. So that is what is required in the assignment, that you need to decide on the alternatives. You may label the alternatives or you can just keep it as alternative 1, 2, 3, 4. Generally, as ma'am said, 3 would be a good number, because more alternatives, more difficult it becomes to estimate. So you can decide on the alternatives, then decide on the various attributes which you want to keep for these alternatives, and for each attribute, what are the various levels. So you can range your levels from 1, 2, 3, 4, whatever you think is reasonable based on the literature and based on the focus group discussions. So based on that, you can decide on your levels and the attributes. So in our study, we had chosen the 5 attributes. So there were 3 alternatives. First of all, we have like 1 to 5 star, we all know. So we categorized 4 and 5 star as a high star labeled car. So that is like the best alternative, most efficient, fuel efficient car. So that I call it as high star labeled car. So it's like star 4 and 5. That is my first alternative. Second is your moderate star labeled car. So that is like a star 3, a middle range. Third could be like a status quo or a unlabeled car, star 1, star 2, lower labeled cars. Or you can say presently we don't have much of these labeled cars. So these were the 3 alternatives which we had decided in the choice experiment. They were characterized by these 5 attributes, starting with price. Price is the most important attribute of the all. We have mileage, kilometer per liter. So it's like we wanted to see how fuel efficiency, your label and mileage. So to document the impact of the 2, we even included an interaction term which I'll show in the results part. Then we included engine, transmission, and the last attribute which was for the network effect, social network. So one way where we captured the intrinsic motivation was through Likert scale questions. Second way in which we captured the social network was as an attribute. So the social network is measured by the market share of friends, family, neighbors, colleagues. So how much of your friends, family, neighbor, colleagues are buying these energy efficient cars, fuel efficient cars. So say 20% of your friends or neighbors are buying, or 60% are buying. So how will that influence your choices? So for each of these, the levels are stated. So starting with the price. So price you could document as an absolute number also, like it was done in ma'am's paper, ranging from rupees 15 to rupees 300 for the fruit rice crop varieties. But we did another novelty, that we tried to include price as a percentage rather than including it as an absolute number. So for including price, we asked the respondents, okay, at what price are you willing to purchase a car in near future? So each respondent had stated in the questionnaire the price at which they are willing to buy a car in near future. That price, we call it as a reference price. So we asked respondents, are you willing to pay 10% higher than your reference price? Are you willing to pay 20%, 30% higher than your reference price, 40 or even say 50% higher than your reference price? So we ranged prices from 10% to 15% of the price which car which you are willing to buy in near future, say in next 1 to 2 years. So that was the first attribute with 5 different levels. Second attribute which we included in our study is mileage, measured in terms of kilometer per liter. So for each of the 3 alternatives which we have, high star, moderate star and unlabeled cars, we kept a different mileage level. So for high star labeled car, the mileage was being kept at 20 or 24 kilometer per liter. For moderate star labeled car, the mileage was being kept at 16 and 20 kilometer per liter. And unlabeled, we kept it at 13 kilometer per liter. So interesting twist which we added to this choice experiment was, we wanted to see, say if they have same mileage at 20 level for high star labeled and moderate star, then which one are they willing to buy? Do they consider labels? So we kind of created like a discontinuity in the design by having same levels for the high star and the moderate star label mileage. Mileage for high star and moderate star, same level of 20. Then engine power, the size of the internal engine, which is in Delhi generally varying from up to 1000 cc to 1000 to 1500 cc and then more than 1500 cc. Then we have included transmission. The levels for transmission, we take it as manual, automatic. And last was your social network. So it's the peer pressure, how is that impacting your choices? So market share among friends, family, neighbors, colleagues. So we fixed it at 20 and 60%. So 20% if of your friends are buying, then you consider buying, or say 60%, as high as 60%. So these were the attributes which we included in our 5 attributes which we included in our study and their levels. Then after deciding this attributes and the levels, the next step was to create choice sets. So as ma'am mentioned, if we could go with a full factorial design, but if we go with the full factorial design, so it will be, let's say, 5 into 3 into 3 to 2, so close to 480 choice sets. So with the full factorial design, it is virtually not possible for any respondent to answer 480 choice sets. So instead of following the full factorial design, we followed the fractional factorial designs. So we calculated the D efficiency. So without much losing on the efficiency, we designed and reduced the number of the choice sets because we did not wanted to compromise on the efficiency part. So we calculated the D efficiency. So it's like minimizing the variance of the regression coefficients, the D efficiency. So with the efficiency which we achieved was 93% efficiency, we had to design at least 19 choice sets. So taking that at least 19, we get ahead and we decided to choose 21 choice sets. So total choice sets we had taken as 21 choice sets. For each respondent, I had given 7 choice sets for each respondent. So rather than giving again 21 choice sets to one respondent, it was too many. So rather than giving 21 choice sets to one, I divided these choice sets into blocks. So as Adam had already discussed, we divided into blocks. So I divided into 3 blocks and 7 choice sets. So that makes it a total of 21 choice sets for 7 choice sets per respondent. So this is one sample of 1 choice sets out of the 21 choice sets which we had created. So it's like respondent has to choose. So in each of these choice sets, respondent has to mark. So it has a high star labeled car with these bunch of the attributes. So attributes like say it is 40% higher, mileage is 20, engine is up to 1000 in this, automatic 60% of my network are buying these cars. So based on that, you choose one alternative. So either high star, moderate star, or you don't want to pay anything higher and you go with the status quo alternative. So this is one possible choice set. So you can observe here we are getting market share as 60-60. So that is possible. All the different combinations are being created. So in some choice sets you might have 20% and 60%. Some choice sets 60-60. Some choice sets 20%, 20%. So a different combination of all the attributes. Making of total of 21 choice cards which we created. So next was the implementation part. So we decided to conduct this survey on South Delhi and East Delhi. So why we chose South Delhi and East Delhi? Because in South Delhi the people were more affluent as compared to the people in East Delhi. So this we tried to capture by measuring the land prices in South Delhi were much higher as compared to the land prices in East Delhi. So we can clearly categorize. I wanted to see two extreme parts of the Delhi. So out of the total 9 districts in Delhi as per census 2011, we choose 2 districts, South Delhi and East Delhi. We did a total sample of 504 respondents. So there were 252 respondents in South Delhi and 252 respondents in East Delhi. Then within South Delhi and East Delhi, I divided them into 3 sub-districts of South Delhi, 3 sub-districts of East Delhi. So I interviewed 84 respondents per sub-district. So making it to a total of 504, 6 sub-districts. So total of 504, 252 East Delhi and 252 South Delhi. We targeted middle to high, upper middle income class families because these were those who will be willing to buy a car. We don't expect a lower class family to buy a car, or chances are higher for a higher and the upper middle class families. So we interviewed those respondents. So here we followed the split sample approach. So like out of 252 respondents of South Delhi, half were given with the incentive treatment and the other half was not informed about the incentive. So half were informed about the regulation. Like if they buy a high star labeled car, they'll be able to drive that car on all the days. So they were informed about that regulation and other half sample was not informed. So a split sample approach which we followed both for South Delhi and East Delhi. So a total of 252 respondents were informed about the regulation and 252 respondents were not informed about the regulation. So before I move to the results, if you have any questions here. Yeah. So we have covered the choice experiment design and the sampling strategy. If you have any questions, we can take. Otherwise, we'll move to the results part. Yes.
How did you come up with this number of 504?
That was, we thought that we should have at least 500 respondents. So based on that, we decided 504. So as to model and have the accurate choices. Anything else? Okay. So these were the results. So these are the tables which is giving the summary of the socio-economic characteristics which we studied. So we included age, gender, And you will see later on how I incorporate these socioeconomic characteristics in the willingness to pay estimates as well. So we took age, gender, are they married, household size, household income, which we ranged from less than 5 lakhs to 5 to 15 lakhs, 15 to 25 lakhs, and income of more than 25 lakhs. We had education, are there high school, graduate, postgraduate, or much higher than that? Occupation, are they involved in service, business, or they are not working? So following our split sample, so all my estimates I report for one, which is the not informed sample. So sample where we do not inform about the driving restrictions. And second is the informed sample. So where we are informing that you buy high star labeled car, you can drive on all the dates. So if we compare the two samples, so that was actually very good, that results which came out, that the two samples were almost similar in terms of the attributes. So we did a two-tailed t-test to check the two samples. So what we found out, only in the number of cars owned by the respondents, there was a slight difference, which was a marginal difference of 2.04 t-value. So but for all the other attributes and for occupation other, the two samples are similar. So that kind of justifies the split sample approach also, that my two samples are similar across the socio-economic attributes. So 252 respondents not informed, 252 informed. So the average age was around 40 for both the cases. So you can read through this. Second, we tested, are the two samples also similar across the behavioral motivations? So we have given all the Likert scale questions which we have just talked about: intrinsic motivation, extrinsic motivation, social interaction, and environmental knowledge. So this table includes the list of the questions with the values as well. So we have seen for the informed and the not informed sample, again, like say for extrinsic motivation there is a slight difference, but for rest most of the questions the two samples are same. So which again justifies. Yes. Yeah?
Could you please zoom in a little bit from the questions?
These questions we have already covered.
Your slides, you can't see it.
I'll try. Is it fine? These tables are actually small. Is it readable now? You can read this first part then. So these are just the intrinsic motivation questions which we had covered. I had already talked about, I feel personally obliged to save energy. While purchasing household items, I take into account how my use will affect the environment. Same questions. So these questions we had separately talked about. Is it now readable? Neela. Maybe I can open the paper and show the results table from there. Yeah.
It's okay. I think it's too much of text, so maybe you can.
These are just giving the values. I'll go from there. So that was what was being shown, where these are just giving the mean values for the various behavioral motivations which we have. And the idea was to compare the two samples, like informed and the not informed sample, are they similar or not? So next which we talked about was the So for estimating these results, so we adopted 3 models: conditional logit model, random parameter logit model, and the latent class logit model. So Sangeeta ma'am has already talked about the conditional logit and the random parameter logit. So that's why I did not included them in these slides. So these are just for those who are interested in the little bit equation part, covering it from where ma'am had actually left. So we are aiming to maximize the utility for individual n choosing alternative j. So j stands from 1 to capital J. So this will be my utility function, same as what ma'am had given. But for each conditional and the conditional logit model, it basically assumes homogeneous preferences. So considering that we may not prefer a conditional logit model, we might want to go for a random parameter logit model. So in random parameter logit model, we are allowing the heterogeneous preferences. So we are allowing the preferences to vary. But the random parameter logit model, it allows all the coefficients to vary except the price coefficient. So in random parameter logit model, we keep price coefficient as fixed and all the other coefficients are varying and they are following a normal distribution. So these conditional and random parameter are already covered, so I'll not go into detail. I'll go more into detail of the latent class logit model, which was not covered. So in random parameter logit model, it's a latent class is a part of a random parameter logit model. But what we do here is we are assigning it into various segments or the various groups. So each individual is characterized into different groups. So it's like the utility of the individual will be same within that class, but the utility will be differing across groups. So it's like, say, you can classify into 5 classes or 5 groups. So within a group, all the individuals have more or less same preferences. So that's the idea of this. So if you say have like an endless number of the classes, endless classes are there, then the random parameter logit model will be converging to a latent class logit model. So we incorporated these conditional logit, random parameter and latent class logit models where we identified the number of the groups. So I'll be talking about how we identify these groups. So in terms of the equations, the first part, so like in MAM, it was the probability of individual n choosing alternative j. So same this probability equation which MAM had talked about, it's the same equation. But here there is another variation, is probability of individual n choosing alternative j which is belonging to class G. So for which class you are belonging, based on that, what is the probability? So these probabilities we'll be estimating it through stata. So that is the first. And the second part is, if we are allocating each individual to G number of classes. So how we allocate the individual to different classes. So based on the socio-economic or environmental characteristics which we follow in this, you are allocating each individual to different classes. So the probability of an individual n belonging to class G. So this is the second. So the final unconditional choice probability of individual n choosing alternative j will be the product of the two. So here x is the, ma'am had already talked about, it is the vector of the attributes. Beta is the weight assigned to that attribute. Alpha is the parameter vector for class G, and Z is your socio-economic characteristics like say age, gender, income, different equations which is you are classifying it into the group. So your unconditional choice probabilities will be the product of the two. So any questions you have before I go into the results? Yes.
You mentioned that you had taken You mentioned that you had taken middle class and upper class
Yeah.
as your sample. But you also mentioned that your income categories were up less than 5 lakh, 5 to 10 lakh, and maybe, if I'm not wrong, above 25 lakhs, right?
Yeah, yeah.
So I was not able to understand that how, would your middle class and higher income class would fit into the annual income of 5 lakh and.
We basically interviewed the respondents who are located in good localities of Delhi. So, like, say, Kalkaji Defense Colony. So, that's how we picked up the different districts.
But I think maybe I'll just rephrase the question. What I meant was that, how would a person earning, let's say, 5 lakh come under the middle class category? Because I think you are grouping it on the basis of income. And you mentioned 5 lakh also as your maybe the first this thing. So I was not able to figure out that, if a person is a middle class person, how would, he be able to come under the annual income of less than 5 lakh?
Yeah, that we did not specifically did the distinction.
The thing
Yeah.
I could say in that respect is sometimes, uh, so we know they are middle income class, if I understand correctly, because of the neighbors where they live, that we could with certainty say that they are thought as being as middle income class. Usually when we ask people to report income, it's okay to go kind of down in the scale, even if it looks a little bit unrealistic, because people tend to underreport income a lot. So in that respect, is that even if they underreport income, the fact that they live in those neighborhoods kind of reveals that they are middle income class people by living there. And as I understand, we went to knock at their doors, right? We were knocking at houses. So, well, no we, right? Clearly, it wasn't me. It was Charu. But that's how we know they were middle income people, because they were living there. But the income, yeah, that is a big problem when you ask people to report their self-report income. Yeah.
Any other question? Yeah.
Ma'am, I have two questions. First is in that model, I have seen weights for the attributes in the later slide.
Which?
We'll go to later slide.
Okay.
That.
That's a very interesting part of the paper. But
Yeah.
we'll come to that.
Another question is because I am seeing you are taking two different groups, groups like one is informed and another is not informed. So, like, can we use a propensity score matching for matching the individuals, because you have a quite large sample size also. So it will be more realistic to compare than those two peoples. Like somebody is in a higher income group, like not in just higher income, maybe all different parameters when we do a propensity score matching, and then we can compare them both based on their status, based on their score.
Yes.
Can we do that?
I like that question. I like that question because I have thought about it in the context of latent class models. So the easy way to implement your idea is what we are doing, which is basically we are we are going to run the regressions, and basically we are going to say whether average preferences are different or not, just as they are. By doing this, that has no weights, that has no propensity score. And so far, we are following protocol, right? Which is usually the common answer. But I have thought about the fact that by having this type of a split sample, that in this case might not be needed, but in some cases the split samples don't come out very nicely. Here, this work was, the reviewer said it was very good, and we are really happy that the reviewer pointed it out, because as you saw in this and in the other one, with the exception of a very few variables, they are very similar. But what will happen if split samples where in some cases they are not that similar? I have thought what you are saying. Should we carry out comparisons where we do the propensity score, we say, well, look, in this sample, and this sample, these are the people that look more similar. And when we do the comparisons, we are going to weight more those that are more similar and weight a lot less those that are not similar. That should be possible, right? It's a probit, and we run the logic. So we run the probit, we assign weights, and we carry out that. Okay, that I think that he's proposing kind of a methodological advancement, because I have not seen people doing it. That will be a way to control a posteriori for similarities. So good point. Kudos. And the other thing I want you to understand and think about when Charu starts explaining the results of the latent class models is that somehow latent class models is a method that identifies differences in preferences conditional on being kind of similar within groups in the observables. Implicitly, what the model behind the scenes does is it groups people and says, these people kind of look similar, this group and this group, and it's funny because they react differently. That's the basic logic. The EM algorithm that is behind these methods, EM for expected maximization is the name of the algorithm. The first time I wrote it, it took me like 2 months because it was so easy to start, and it was so unintuitive that it was going to start so easy. But basically it starts by randomly, just arbitrarily assigning people to one group and to the other group, and start comparing preferences. And then it converges when the groups are similar, but they are very different in preferences. Very similar as similar as possible in observables, and very different in preference as possible. That's the basic idea. And I wanted to relate that to your question. In many respects, it's a propensity score. Because the idea is, how can I find people that are very similar in observables, but that they behave differently? So the latent class is another type of propensity score, but that conversation hasn't happened. There is no, I haven't seen papers describing the latent class models as a type of propensity score. So there we have another methodological conversation.
Sir, I have one more question. Or maybe I just want some clarification regarding this. So propensity score matching, is it not the same sample that we consider and then we give them a treat, then let's say we give them any, for the same sample, firstly, let's say they are not, let's say tested upon some policy matter. And then, for the same sample, when we give them the policy and we try to figure out how, what is the difference in terms of the treat. So in her case, she has clearly mentioned that, there's one sample where she has actually informed them about the incentives, and for the other sample, she has not informed them about the incentives. So I'm not sure if we can use the propensity score matching here, because it's not like that, earlier they were not given the incentive, and, suddenly they have been given the incentive. And to figure out the difference between the same sample over, incentive versus non-incentive. So, correct me if I'm wrong.
Yeah, no, in this case, the treatment, what happens in this case is that we don't have the before and after. Yeah. That's the part where it becomes a little bit messy. You are right in that respect. We are very used to use propensity score matching with a before and after idea. Yes. But in this case, even when there is no before and after, you can always say, well, what was the probability that I randomly, not too well, assign people into the information sample versus not, and basically you try to put in both, try to pick those that are the most similar in observables in both groups, because what is going to happen what is going to happen is that if these don't look too similar, that means that if you run a regression assigning to the information sample, you are going to obtain positive coefficients in these observables. With these coefficients, then you can pick a sample that makes it as similar as possible to the other one, so that those coefficients are not similar. Does that make sense? Let me repeat it because I realize I didn't explain it well. In this case, the split sample idea, instead of thinking on the split sample idea as the probit, think it in this following way. You are comparing two samples that are not too similar, and you say, oof, I didn't do too well my split sampling. Now, imagine the following. You pick up a random subsample from each category, compare them, or run a probit where the probit, the dependent variable is 1 if I assign you to the sample 1 versus 0. If the coefficients don't come significant, or if this becomes more similar, then it's as if you were doing a propensity score, because those subsamples that you pick randomly are more similar now than the initial samples. Does that make sense? Did that make more sense? It's similar to a split.
I get that. So maybe we can.
Yeah, we can continue? Okay, sorry. Oh, no. Yeah.
So we'll continue. So we have talked about the conditional and the latent class logit model. So now I'll be going to the results part. So these data codes, we'll be running them afterwards in a separate session, maybe in tutorial, because we will not be left with time. So where we'll talk about these. So we had done three models which we had run. One was the conditional logit model. So the code which we generally use for a conditional logit model is the dependent variable. So in our case, the dependent variable is the choice variable, which is taking value 0 or 1. So like which alternative you are choosing, high star, moderate star, or an unlabeled. And then you can have a set of the independent variables, which will be like all your attributes. So we even include high star, moderate star as one of the attributes, price, mileage, engine, transmission, network. So a set of the attributes, and then the group, each respondent is being assigned a group. So these we can try them separately in Stata. So these were the results which we reported for the conditional logit model. So the conditional logit model is a restrictive model because we assume homogeneous preferences. So it's not much preferred. So we reported them in the appendix. We more focused on the random parameter logit and the latent class logit model. So I'll skip them and I'll more now go to the latent class part. So overall, if we see, we report them for the not informed sample and for the informed sample. Then we do the another addition which we add is interaction and the not interaction term. So we want to see how your high star label and the mileage, because it's like there has to be a collinearity between the two. If mileage is increasing, should be that your label is better. So we kind of include an interaction term between the two to see how high star and mileage interaction changes my results. So I'll focus on the interpretation of the random parameter logit model. So same way this is the Stata code for the random parameter logit model. So where the code is mixed logit, dependent variable which will be your choice, independent variables the set of all the attributes. So in random parameter logit model we have heterogeneous preferences. So we assume all the parameters to vary except price. So price is kept as fixed. So I'm defining the random variables, which is your alternative 1 stands for high star labeled, alternative 2 stands for moderate star labeled, your mileage, engine, transmission and network. And price is kept as separate. And then we are grouping each respondents into the groups. So these are the results of the random parameter logit model. So what we see here is, some beautiful results which we get out is, one is the price coefficient. You can say it is similar at 0.006 for all the cases, for not informed as well as for the informed sample, as well as for no interaction and the interaction cases. All the other coefficients, my high star label, moderate star, mileage, engine, so these other coefficients are also significant and they are more or less in line with the expectation. So it's like, say, if engine increases, it's more than 1000 cc engine, say your utility is increasing. So for price, we have a negative coefficient which is expected, because as price increases, your utility will be falling. So then all these coefficients are positive and statistically significant. One interesting result which we see out here is the network coefficient. So we see the network coefficient in the informed sample. So you can see here. We can get a pointer. Yeah. So here you can see it is 0.0032. So this is insignificant for the informed sample in both no interaction and interaction. So that means when driving restrictions comes into play, the peer pressure network effect is not that important. What is more important impacting is your regulation. But in the case of the informed sample, it is significant, the network coefficient. So rest all the coefficients are significant.
You can also talk about difference in the high-star label coefficient.
Yeah. So in high star, I was thinking to talk in willingness to pay. We can cover here also. Because willingness to pay will better give them more relatable results. So then we calculated the willingness to pay estimates. So these are like the betas which ma'am had also talked about. So beta coefficient of the high star label divided by the beta coefficient of the price. So beta coefficient of the moderate star label divided by the beta coefficient of the price. So through that we calculate the willingness to pay, which is being again done for the not informed and the informed sample. Then we do a two-tailed t-test. So we want to see, like, is regulation changing my preferences for all these attributes. So we see in terms of the coefficient for high star label for a no interaction, we have a willingness to pay of 4.936 thousand USD. So we converted all the prices into 1000 USD values. So it is 4.936 for a high star label, which is much higher than the moderate star labeled car. So we can clearly see that people have preferences for a high star labeled car. Next, if we compare it for the not informed sample, it is 4.936. And for the informed sample under no interaction, it is 7.481. So that is how the willingness to pay for a labeled car is increasing when you buy a high star labeled car with the regulation. So like when you have driving restrictions, so like with high star label there is no driving restrictions. So you are willing to pay more from 4.936 to 7.481. So the difference between these two willingness to pay is close to, I think, 2.55 thousand USD. So this is the cost of the regulation. So if you are imposing a driving restrictions and where there is no driving restrictions on high star, but for others, your cost of regulation is 2.55 thousand USD. So this might seem a high number, but if we compare it with the previous literature, so there is a study by Blackman which did this study for Mexico, Mexican Hono Circular Scheme, and there it had estimated the regulatory cost as 2.96 thousand USD. So it's almost similar to what we are finding it in the literature. Then you can see, so that's the one result which we found out, the cost of the regulation. Then we conducted a p-value test. So you can see if we take it for a no interaction case, the p-value is 0.31. So it is statistically significant. So you can see when we are informing the sample about the regulation, their willingness to pay is increasing for a high star label, and it is significant for a high star, both for a no interaction as well as for the interaction. But if you compare it with all the other attributes, it is not significant. Because so these results are in line with what we expect, that for a high star label, regulation is playing a role, which is not playing a role for the other variables. Then you can clearly see the willingness to pay. Let's say take this 200. So for a high star label, it is 6,000 USD. For a not informed sample under interactions, it increases to 13.46 thousand USD for an informed sample under interactions, and its p-value is 0.04, so the results are significant. Next we see the mileage. So people are willing to pay 0.2 thousand USD for a mileage under interaction, not informed sample interactions. It increases to 0.55 for the informed sample under the interactions. So with this you can interpret. So if there is an increase in 1 kilometer per liter, it decreases the willingness to pay for the best efficiency label equivalent to 350,000 USD. So that's how this willingness to pay we are calculating. So this was what we did for a random parameter logit model. Then like ma'am had talked about the demand curves. So another beautiful thing which we incorporated in this is we estimated the demand curves. So these demand curves, we estimated it for two scenarios. Similarly, like not informed sample and the informed sample. So for the first, these demand curves, we did it for two alternatives, high star labeled car and the moderate star labeled cars. So like all the demand curves are downward sloping, we founded our demand curves downward sloping. But one interesting result which came out. So here we assumed mileage as 20 kilometer per liter, engine as 1000 to 1500 cc, manual transmission and 20% network. So taking these parameters, we formulated the demand curve. So the one with the blue dots is showing the no driving restrictions, with the orange dot is showing the driving restrictions. So you can clearly see that my demand curve is shifting towards right for the high star labeled car. But if we see it for a moderate star labeled car, the demand curves are almost converging. They are almost the same. So this clearly indicates when you have a driving restrictions in place, when you are informing the sample, your demand curve is shifting towards right. So that is another result which we found out. I think I'll cover and then take questions in the end, because we are left with a lot of topics.
At least
Latent class. Theta we can do it separately, but I want to cover the latent class. So next is, we estimated the third model which we estimated was latent class logit model. So under the latent class logit model, like we all know, random parameter logit model converges to the latent class logit model for endless number of the classes. So my first task was to identify the number of classes. So I took the classes starting from 2 class to 6 class, because 6 was also a reasonably high number. So from 2 to 6 classes, we estimated the information parameters. So we estimated AIC, Ekai information criteria, and BIC, Bayesian information criteria, to see how many number of the classes we want to decide. So that we did it for no interactions and the interactions case, for the not informed and the informed sample. So based on BIC criteria, if you see for an interaction case, the BIC is increasing from 3 to 4 classes. Similarly, it is increasing, a very high increase for informed sample from 2520 to 2557. So clearly you can see when we move from third class to fourth class, at least for the interaction cases, the BIC values are increasing. So taking that into consideration, we decided to choose optimal number of classes as 3. So after deciding these optimal number of the classes, I started to classify the respondents into different classes. So to classify the respondents into different classes, I considered the socio-economic characteristics and the environmental attributes. So the socio-economic characteristics which I included to classify the respondents were age, income, gender, education. So these were the four most important socio-economic characteristics in which we can classify the respondents. So age, like we took it less than 30 years, 30 to 50 or more than 50. So these how we classified the respondents into age. Income, it's already classified less than 5 lakhs, 5 to 15, 15 to 25, more than 25. Education, again high school, graduate, postgraduate. Then second which we included was the environmental factors. So I took all the Likert scale questions which we had talked about: intrinsic motivation, extrinsic motivation, social interaction and environmental knowledge. So taking both socio-economic questions as well as the environmental knowledge, I classified the respondents into different classes. So we classified into 3 classes, and then based on their attributes we also assigned a label to those classes. So we assigned these 3 labels: intrinsically motivated adopters, extrinsically motivated adopters and non-adopters. So these are my 3 classes. Class 1 is IMA, class 2 is intrinsically motivated, EMA and non-adopters. So the class 1, which is intrinsically motivated adopters, they were like older age group, more than 50 years of age, those who have higher income, they were more educated, they were male, and they had high on all the environmental attributes. So high intrinsic motivation with environmental knowledge, high social network, high in social interactions. Second was the extrinsically motivated class. So these were those class where we documented the peer pressure effect, where their friends and neighbors were more influencing this class. So we named them as intrinsically motivated class. They included middle-aged, middle-income people, educated, both males and females were there. They were average in intrinsic motivation and environmental knowledge, but they scored very high in social network effect. In intrinsic motivation, they were ranked the highest. And last were the non-adopters who were not willing to pay a very high amount. They considered young age, low income individuals, more of the females, and who were scored low on all the behavioral motivation scores. Then these are the percentage values given for each sample. So IMA consisted of 30 to 36%, 40 to 52% range is for EMAs, and non-adopters is a comparatively lower range ranging from 18 to 24%. So these were the logit model codes which are there, same like we have in conditional logit. So LC logit, dependent variable, independent variable, group and ID name. Then you have to specify the number of classes. Here I've chosen 3 classes. Then in membership variable list, you will add all the socio-economic variables which you want to include. So example could be age, gender, income, education, so that you can include it in the membership on the basis of which you are classifying different classes. So these were the results which we got. So these are the results for the not informed sample. So here we have reported separate results for not informed and informed sample by 3 classes: intrinsically motivated, extrinsically motivated class and non-adopters. And again we did a separate for no interaction and the interaction case. We'll just talk about these. Similarly, we do it for the informed sample. So if you see, the willingness to pay is much higher for a intrinsically motivated adopters. On a non-informed sample, it is 3.788 thousand USD for a high star labeled car. Under interaction term, the willingness to pay is 5.23 thousand USD. If we compare this willingness to pay for a high informed sample, this willingness to pay is increasing significantly for a high star labeled car. So which is 4.961 for a no interaction and 8.634 for a intrinsically motivated adopters. So one is the intrinsically motivated adopters are willing to pay most for the high star labeled car. Their willingness to pay is the highest. So IMA report the highest for the best efficiency label and mileage. And it is the only group where interactive term is more significant. Whereas for extrinsically motivated adopters, the willingness to pay is second highest for the best efficiency label in the informed sample, but they report a significant willingness to pay for mileage in not informed sample. So if we see the results for EMA, it is the only group where peer pressure effect is most important. So here network is important for a extrinsically motivated class. So these are comparing the willingness to pay for the not informed sample and the informed sample in terms of the three classes. So you can clearly see the willingness to pay is higher for intrinsically motivated 31.44 thousand USD compared to EMAs, which is 2. For non-adopters, this willingness to pay was insignificant. If we see it for the informed sample, it is very high, 57.98 USD, 1000 USD. So what we see is, okay, first before I'll just show you, we even calculated the average values for the each class. So what is the average value for each class for the different parameters? So for intrinsically motivated, extrinsic, social interaction and environmental knowledge, we calculated their average mean values. So you can, from here we basically, by calculating the average mean values, we try to classify them into 3 classes. So it is 0.69 is the intrinsic motivation, which is highest in IMA. Extrinsic motivation is also very high, 0.69. Their social interaction is high. Environmental knowledge wise also they are high. So this indicates that this class is more concerned towards the environment. Whereas if you see here, within this class, for this class, intrinsic motivation plays one of the important role for a not informed sample. So that is what we found out. So if you have to give the conclusion part, I can say that the car drivers are willing to pay more for the fuel efficient label cars, and their willingness to pay is much higher for a high star labeled cars. So this willingness to pay goes beyond the fuel savings. So we even estimated the fuel savings which could be expected if you are buying a high star labeled car, assuming that say you are driving 12,000 kilometers in a year with a average mileage of 21 kilometer per liter. So this willingness to pay, we found out, was much higher than the willingness to pay arising from the savings due to fuel efficiency. They attach a willingness to pay of 6,000 USD to the efficiency label, which is 30% of the price of the car respondents would be willing to buy. Label is working the most for the extrinsic motivation class because that class is willing to pay the most. And for extrinsically motivated class, which is representing around 52% of the sample, 40 to 52% of the sample, here the peer effect plays an important role. So basically we found out the policy implication is that these regulations could actually increase the willingness to pay. So with that I'll conclude and we can now take questions. Yes.
online, we'll take an online also.
Ma'am, I had one question regarding the methodology. This is very new to me. So when you are you dividing your results into basically the you have not made them aware about the policy and the other one. Can't we use it as a variable in the controls, like one if they have been informed and zero otherwise, or is it the method that doesn't allows us to do that? Similarly, when you are dividing it into different classes, you are calculating it separately, and then you are taking a t-test separately to see if there is any significant difference or not. So is it not possible to do it the other way, or will it have some implications in terms of how we interpret the results?
Adin, would you
Yeah,
want to take questions?
I can participate.
Yeah,
in
maybe
that.
he can take questions.
Yeah.
One of the first question is why don't we include actually the dummy in the regressions, and that is definitely possible. But in this type of specifications, that will have mean that we have to interact the dummy inform with all the other variables, and then the convergence gets a little bit tricky. And what we lose by doing it in a split sample is standard errors, right? Like if we do it all pool, the standard errors are lower. If we do it separate, the standard errors are larger. So if we are finding differences here, even with larger standard errors, that means that when we pull it, we will find them anyway. And the other question is, and that is something we will discuss in the next session. When you do what we did here to allocate in different groups, once the latent class tells you there is 2 groups, and then compare as we did, we also should be controlling for standard errors because it's a little bit of an instrumental variable approach. We didn't do it, but we should be doing some sort of penalizing the standard errors for imputing you into a class. But that is something that we should discuss a little bit in the next session. Yeah.